In this video, we will learn about similar figures. Please open your packet to page 5. Similar figures are shapes that have the same shape and angle measurements. Similar figures' corresponding sides are proportional, and corresponding angles are all congruent. That means that the shapes look the same, except they may be scaled to different sizes. For example, in number 1, we have a smaller triangle and a bigger triangle. But if you notice, to go from 3 centimeters to 15 centimeters is times 5. To go from 4 centimeters to 20 centimeters is times 5. So we can assume that to go from A to 25 is also times 5, because we're told that these are similar figures. When you hear the word corresponding sides, what that's referring to is the sides that are in the same position in the shape. So for example, we have a shorter side in each of our triangles, a medium length side in each of our triangles, and a longer side in each of our triangles. The angles would also be the same. So this angle down in the bottom left-hand corner is the same as the angle in the bottom left-hand corner of the next triangle, etc. This just happens to be the way that the shapes are oriented or positioned on the paper. If you jumped ahead to number 2, you'd see that the angle at the top corresponds to the angle at the bottom. Now let's look at how you can solve for a missing side length. There are multiple ways to set up the proportion. Now, we already saw that in our 2 triangles, we can compare the corresponding sides of the small triangle to the corresponding sides of the bigger triangle, or the left triangle to the right triangle. So, we have our side length that's 3 compared to our side length of 15, and this should be the same as our side length of 4 compared to our side length of 20, and this again should be the same as our side length of A compared to our side length of 25. We don't need all 3 of these. We could have chosen to use the green one or the yellow one with the blue one, and then we can solve the proportion just like we normally would using our cross product. So we have 4 times 25 equals 20A, which means that 100 equals 20A, and A equals 5. This makes sense because we had said before that we had to do 5 times 5 times 5, and now 5 times 5 equals 25. Notice that in our key we had small over big. Each of our numbers in the numerators, or the top of the ratios, are from our measurements in our small triangle, and each of the measurements in the bottom are measurements in our larger triangle. We could have also set up the proportion in a different way. Still continuing with the same problem, we instead could look at the ratio of 2 of the sides within the shape. For example, our 3 to our A should be in the same ratio as our 15 to our 25. So we have 3 to A equals 15 to 25. Each of the numbers in the numerator here are our green sides, and each of the numbers in our denominators are our blue sides. It doesn't matter as long as your numbers in the top of your proportion have something in common. Your numbers in the bottom of your proportion have something in common. Notice that the 3 and the A are both from the left triangle, and the 15 and the 25 are both from the right triangle. Or again, this is our big triangle on the right and our small triangle on the left. When we solve this proportion, we get the same answer, because 15 times A equals 75 gives us an answer of 5. Try numbers 2 and 3 on your own. Remember to pay attention to which sides are corresponding. For example, in number 2, we know that this side on the bottom will correspond with this side on the top, whereas the other 2 sides of our isosceles triangle will correspond to each other. You can set up your proportion between the 2 triangles or within each triangle, comparing one of the sides to another side. Now let's jump down, and I'm going to do example 4 with you. Sometimes you'll get problems like this, and you have to think a little bit about which triangles we're comparing. Notice that we have a smaller triangle in here, And then we have a larger triangle, which is the full figure. It might be helpful if you draw each of these triangles and put the measurements on them so you see it as two separate shapes. My smaller triangle has a side length of 18, and then the other length, which is the hypotenuse, or the longer side in the right triangle, has a length of 24 yards. In my green triangle, or the bigger one, I have 18 plus 12 for the bottom side, which adds to 30, and then I have x for my longer side. Now I can set up my proportion. So I'm going to do my smaller figure compared to my larger figure, or the left one compared to the right. So to go from 18 to 30 should be the same as going from 24 to x. And now I'll solve this proportion. 30 times 24 gives me 720. And on the other side, I have 18x. Now, I want to divide both sides by 18 because it's the inverse operation of multiplication, and that will isolate x. 720 divided by 18 is 40. And I always want to check to make sure that this answer makes sense. So, does 40 seem realistic? Yes, it does. And I could check it by saying 40 is to 30, so 4 over 3, as 24 is to 18. And that's true. 4/3 is the same as 24/18, so I know that my answer is correct. That's the end of this video. Try the other 3 problems on this page, and if they make sense to you, then you can jump into the working class. If not, we'll go over them in class and I can explain anything you're confused about.